Good evening. I'm going to show you quickly how to create a water or land mass using a couple of different modules in ArcGIS 10.3.1 using Landsat Thematic Mapper data. And we're working in Northeast Illinois in the Chicago area, so this will work fairly well for any place where you have a substantial amount of land and water for creating either a water or a land mass. If you look here, you can see that this is northeastern Illinois. Chicago's right here on the shore of Lake Michigan. Lake Michigan is very dark because we're looking at channel 4 in Landsat Thematic Mapper from Landsat 5, and so channel 4 is near infrared. Water typically has very low reflectance in that part of the spectrum. Land somewhat higher. So we start by making sure that the spatial analyst extension is checked and available. And so we look at our extensions, and you should see here on, I think on my extension list, that spatial analyst extension is available to be used. Yes, there it is. If not, you would check that checkbox next to that extension. Our next step will be to check in the toolbox and select the ISO cluster unsupervised classification tool. So you can find that in the toolbox in Spatial Analyst Tools under Multivariate Tools, and there's a tool here called ISO Cluster Unsupervised Classification. We open that, and you'll see the dialog for that tool. Soon. There we go. And in that dialog, you'll see there are a number of options. We're going to use just channel 4, as I mentioned. That's the only channel we need to do this classification. And we're going to make 2 classes. And you can read about the ISO cluster classification, unsupervised classification routine if you like. Check it out in Help. In ArcGIS Help, it's pretty interesting and has many different uses, and this is one of those. And then we'll just leave the rest of these as default. You can see that I can send this. Right now it's going to my default geodatabase. I can send it to another folder if I wanted to. I'm just going to let this go into my default geodatabase because I'm going to use it fairly quickly and probably dispose of it. It's actually a step on the way to the actual mask that we're going to create. So I go ahead and run this. You'll see it runs here for a moment. You can see it's running down here in the bottom of the ArcMap window. You can see that it has successfully completed my cluster, and if you look, there are 2 values in this newly classified image. There is a 1, which includes all of the 0 margin and the water areas, you know, that are even smaller water areas, and then there's also a value of 2 that covers the land areas. Okay, so what I'm going to do is I'm going to take that now and reclassify that, and I can do that again in Arc Toolbox in the in the Spatial Analyst Tools under Reclass. Here you can see we're not in Multivariate anymore. Under Reclass, and use the Reclassify tool. The Reclassify tool is fairly simple. We input a raster value, in this instance the newly clustered file, and it pulls out all the values in there, and we have the old values, which are 1 or 2, and we can assign new values for this. So if you recall, the water value is 1. We want that value to be 0 because we want that to be masked, so I change that to 0, and all the area that we want to show through we'll use the value 1. So we've changed the value for 1 from the water to 0, and the value for 2 for the land to 1. Okay, so we have two new values, 0 and 1, 1 for the land and 0 for the water. Fairly simple. And you can see this also is going back into my default geodatabase. So I'll let that reclass take place, and we'll get a new reclassed layer. Here it is, and you can see now the values for water are 0 and the values for land are 1, and this is our mask. I'll turn off the original ISO cluster, and I can even get rid of that because it appears that we've successfully made it through that process. Right? Okay. So now that we've created our new mask layer, we can use that layer on any layer from this same data set that we choose. So remember, we were looking at channel 4. Here's channel 1 in the visible blue. And if you look at channel 1, look at the turbidity that's visible in Lake Michigan in channel 1. So again, this is one of the reasons we need to use the mask, because we really want to classify land values, and there will be quite a bit of confusion between turbid water, muddy water, and the land. So the way that we do this the masking operation, and here's our mask, right? It's ready to be used. The way that we do that is we use, again, from the toolbox, we use a tool that's in the map algebra tool set called raster calculator. It's the only tool in that tool set. And the raster calculator is a very useful tool. It allows you to build map algebra expressions where you can execute functions between different layers in your current data set. And so what we're going to do is we're going to take our channel 1 here. We'll do this just for one channel right now, and we're going to multiply it. How do we multiply? That's with an asterisk. We're going to multiply it times our mask. Okay, and you can see the result is going into our default geodatabase, which is fine. That's a good place for it. But this is going to be our new layer, so I can actually give it a name, although this name can't go beyond 13 characters with no spaces, oddly enough. This is one of the limitations that we have. So I'm going to call this B1 mask. Okay, and I'll let that run, and you'll see what the result looks like here in just a moment. Okay, so here's our new masked layer, and this is a B1 band 1 mask of this same channel. So here's the original masked, here's the original band 1 layer. You can see the turbidity in the lake, and here's the band 1 mask where every pixel that was multiplied by a pixel with a value of 1 came through with the same value, and every pixel that was a pixel that had a value of 0 comes through as 0, right, because it's being multiplied by 0. So all of the 0 pixels then are fundamentally, they're removed from this new masked layer. So, and here's the mask layer. Again, this looks a little bit different because it's a completely different image, and there's a different stretch, different default stretch that's being applied to that. So it has to do with stretch. The data is identical. The values are identical to the original data on all of the pixels where the value was 1. So, water mask. If you wanted to make a land mask, when you reclassify it, you simply reclassify the water pixels to 1 and the land pixels to 0. That'll mask out all of the land, and you'll only be working on the water. So it's a very useful technique for a lot of different things that we do in remote sensing.